Good evening. How are you? This is Adam Buckner, one of the live trainers here at Unity Technologies, and tonight we are going to look at 2D physics and game mechanics by creating an Angry Birds style game. Now tonight is going to be a relatively dense class. There's a lot to cover in the time slot, and the scripting for this is part way between basic and intermediate. We're doing some interesting tricky tricks to get this to work efficiently. And I will say that I didn't write this. Normally I write all the material that I present, but in this case this was written by the Learn team, and there's some rather interesting solutions that we've come up with to make this work and make this work in a very simple manner. So I'll try to walk you through each one of those steps, especially when we get into scripting the rubber bands that come back on the Catapult. So, start off, let's take a look at the game that we're going to be making. Let's go ahead and hit play, and we can see that there is the typical slingshot that we have, and there's our rock. We're going to launch our rock on the rubber band, and boom, there's our target there in the house made out of sticks. So we're trying to crush the bird. Our game is relatively simple. It's just going to keep reloading that same level over and over again. So we don't have multiple projectiles at this point, and we don't have a lot of the fancy stuff. It's just the basics of how this game's going to work. So let's go ahead and build this game. I'm going to do this from the ground up, so let's go ahead and start with creating a brand new project. So we're going to get started with Unity. We want to start this project, so we create a new project. So let's come up to our file menu and we create a new project. And as a matter of fact, did I remove the other one? I'm going to remove this one off my desktop. Pow. There we go. First thing I want to do is set the path. Where am I going to put this? I'm going to put this on my desktop. What are we going to call it? Let's call this Angry Meteor. Angry Meteor. Why not? So we have Angry Meteor here. One of the most important things about what we're doing today is we're making a 2D game project. And we can set up our defaults for 2D. And this is important for what we're doing. We can always make a change. If we start off with a 3D project, we can change these settings in the editor. But when we're creating it, we might as well go ahead and do that, set up our defaults for 2D from the beginning. So we've created our path, and we've set up our defaults for 2D. And so let's go ahead and create that project. So we have a brand new empty project, and we have a brand new empty scene. And when we look at our scene, we have nothing but our main camera. This is normal for when we come to a new project in Unity. And we can see that we have the setup up here for 2D. We've picked our 2D setup. So we are not in 3D mode, where we would see perspective. We are in 2D, and that was because we set up our defaults for 2D. The other two main changes that we're going to get for setting up our defaults for 2D is if we go to Project Settings Editor, we can see that we are set for 2D. And again, if we need to change that, we can change that here in Project Settings for the editor. And with the project settings set to 2D, we get things like our main camera is automatically orthographic with an orthographic size of 5. So we do not have a perspective camera, we have an orthographic camera. So we're looking at the XY plane, we're looking down the Z axis, we don't have perspective, and our camera is automatically set up as orthographic for us. So now we need something to make our game with. We need some assets. Where are we going to find our assets? Well, if we go under Window and Asset Store, we can go ahead and grab our assets. I'm going to go ahead and grab the 2D pack. The 2D pack is a set of assets that we're going to continue to add to for people to help make 2D games. It comes from Unity. I'm just going to simply search for 2D pack. Hello, Internet. There we go. And here's our Unity Samples 2D pack. So I'm going to look at the page. It comes from Unity Technologies. It's absolutely free. You can use these in any game that you want, in any way that you want to, like anything that comes from Unity Technology. So I'm going to go ahead and import that. And when we import that from the Asset Store, we get a Unity package that's downloaded onto our computer. And then when that's downloaded and decompressed, we should get a nice little window. There we go. Of all of the contents. This includes a number of things, including Hat Trick, the fun catch game that we did in the live sessions a few weeks ago. But I don't want to get everything, and I certainly don't need to have game examples. We're going to add this game to this pack, so soon it will be in the example games. So I'm going to click None. So all of these assets are deselected. Then I'm going to pick up the sprites folder here by clicking that. By clicking the folder, I get all of the contents. So I could choose to turn some of these on and off, but I just want to get all of the sprites. And now I'm going to import that into my project. So when that's done importing, thank you, import assets. There's quite a few sprites here. So, and then also, because we're set up for 2D, all of our images are going to come in as sprites. So we can see that these are all being imported as sprites. So the texture type on the import is already set up for 2D UGUI sprites, not the default texture, because it knows that we're doing a 2D setup. So that's one of the other advantages of having the editor settings in 2D mode. So we've got our sprites in now. So we've got something to work on. These include a lot of sprites that we aren't going to use, and some sprites that we need for our game. So let's go ahead and I'm going to bring up the preview window here. So that's the preview window. So we can see what these sprites are. Some of these, if you've taken a look at Hat Trick, will be from Hat Trick, and some of them will be for this game. So this is a series of sprites that we're going to be using. So the first thing we want to do is let's go ahead and bring our background into the scene. So there's our sky sprite. And let's just simply drag it from the project into the hierarchy. And because it's a sprite, because we have 2D mode set, we can see that it comes in with a sprite renderer. And this is, let's back out here. That's a perfectly good sprite we have there, centered in the middle of our game. We may adjust its size and shape as we move forward. There's our background, and we can set the sorting layer. I'm going to leave this on default at this point. I'll leave the sky as the default background, and then I'll add new sorting layers for the foreground elements for our game. And if you want to know more about sorting layers and order and layer, you can look that up in the Learn site. But the basic idea is that we're going to set various parts of our game on different sorting layers, and then we can order the items in that layer using order and layer. We have our 2D orthographic camera looking at it, which we talked about before. So that's looking flat at our scene. I'm thinking that we're a bit too tight on this background with our orthographic size of 5. And remember, we don't have perspective, but we can change our orthographic size, which basically shows more. It's not really a view frustum the way that our perspective cameras are, which get larger towards one end. This is a cuboid pushing down the z-axis. So we can make that bigger. That looks about right. So let's just make that 10. Let's make that 10. So somewhere near our sprite size. And we will probably adjust this background to fit because we're going to need some more space. But the camera to me feels comfortable when we've got a size of about 10. And now let's put in some ground. We need some ground for to give us some reference. Nice to have a beautiful little sky back there. But let's go ahead and put in some ground. So I want to put in, I'm going to need more than one ground, because if we take a look at our thin grass sprite, we're going to need to duplicate this a number of times. And so I want to make a holder. So let's make a parent game object. And I'm going to reset that to origin. And then I'm going to change its name to simply ground. And this is going to be a holder for all of these grass sprites. So I'm going to take the grass sprite, stick it inside ground. Now I've got a holder for it. Let's just simply call this grass, so we know what we're talking about. And it's looking kind of small in the game view. Remember our game view's down here? So let's let me bring that up so we fill it up. It's looking kind of small. It's smaller than I need it to be. I think that this grass can be bigger for the scale of our camera, bigger for the scale of this game. So I could scale the sprite, but I would rather keep that at 1:1. What I would like to do is scale the sprite on import, scale the image itself. And when we're looking at sprites and the way that they import, one of the important settings is how many pixels on the artwork is assigned to Unity units. And Unity units are usually considered about 1 meter. And if we want this to be bigger in our scene, we actually make this a smaller number. So if my pixels to units goes down to 50, it's now going to be twice as big. I'm going to go ahead and read chat. Will the imported but not used assets increase the size of your game? No, it's a very good question, but it will not. The game is only built based on the dependencies that you have. So you can have extra scenes, you can have extra assets, everything that you need, you know, like a workshop full of tools to be able to build your game. But when you finally build your game, it'll only take the assets that it needs. It'll only build the game with the assets that it needs. So you'll leave all these extra sprites in the project, and it won't bloat our game. It'll only bring over the ones that are used in the game. How do you know the size of the orthographic frustum in world coordinates? You can figure that out programmatically. It's a little bit hard to see. I mean, we can go into 3D mode here. Oops, there we go, and we can kind of see how our camera is working as if it was in 3D, which we're not going to be using, but it gives you an idea that we've got that no perspective box going off into the distance. But if you need to find out the exact screen values to world values, you can do that using some lines of code. And we'll see some of that because we're going to be looking at the mouse position and we're going to be using lines of code to adjust that. So we now have our grass in. I'm going to go ahead and reset that to the middle for essentially no apparent reason, just nice and even. And then how far down do we want it? We can adjust the sprite in the sprite window, or we can adjust the sprite here by grabbing the title and moving back and forth. And it was looking good at about -8, so let's go ahead and leave it at -8. That seems good. But we need more. So I'm going to grab my grass, and I'm going to duplicate it. And there's a shortcut key for duplicate, and that's Edit. And we can use Command or Control D to duplicate. So let's go ahead and do that. Oops, don't move, please. D. And then I'm going to use a little quick shortcut, which is called Vertex Snapping. I'm going to hold down the V key, and you can see that the corners that I'm close to highlight, and I can drag that and snap that to another vertex. So I'm going to grab a bunch of these, duplicate, pick another corner, V key down, and move them this way. So they're, ooh, come back here. Duplicate, V, snap. We may need more as we extend off, but we can build those when we need them. So there's our grass duplicated along the back, very quick. Our ball is going to be bouncing along the ground. And currently, we have no colliders involved in either the grass, any of these grass sprites. We could put box colliders around the grass sprites and then sort of form them around the sprites themselves. But there is a more efficient way of doing that, and that is to use an edge collider. And so I'm going to put this edge collider on the parent. And I'm just going to simply leave those grass sprites there as children to give us the image. And then working in the game is going to be the edge collider, and the edge collider I'm going to leave on the parent. So I can do that by going up to Add Component, and then Physics 2D, and then Edge Collider. And I'm going to zoom in. Zoom in, please. And we can see that there is an edge collider here. I may turn off that sky. Sky sprite's a bit bright. First of all, I'm going to change that to just sky instead of sky sprite. Makes it look a little nicer. And then turn it off. So we can see our edge collider there. So there's our edge collider that we have attached to the parent. Now I hold down the Shift key, and by holding down the Shift key, I can edit the vertices here. So I'm going to just put one at this end, and grab the other one, holding down the Shift key, and put that at the other end, and get that in sort of relatively close to the corner. Holding down the Shift key brings up the Vertex Editor, and then do that again on the other side. Just visually right there on the end of the grass. And the reason I'm putting it on the bottom of the grass, right there on the top of the dirt, is so that our asteroid and things that are supposed to be bumping into the grass will settle in behind the grass and land on top of that edge collider. Just as an aside, we can add vertices to, whoops, undo that please. We can add a vertex, and our edge colliders can be relatively complex, but in this case, using the undo to take it back, I simply want 2 dots with a line in between, 2 points with our line in between for our edge collider. Now, when we're sorting these, if we take a look at our grass, we can see that these are also on the default sorting layer that we have for the sky. I want to create a new sorting layer and bring these forward. I want these the most forward thing in the game. So I'm going to my tags and layers, and I'm going to create a new sorting layer. And this new sorting layer is going to be my foreground. Foreground. There's our foreground layer. And then when we come back, I want to assign all of these grass units. I'm using multiple selection. I'm selecting all of that grass and I'm assigning them the foreground. So I've got the foreground assigned. And then I'm going to give them an order and layer since these are going to be, I'm going to have a number of things in the foreground. I want them at the top. So I'm just going to give them an order and layer of 10. So they pop up there right towards the top part. So the next part is to build our catapult. Adding a node to the edge collider is just a case of clicking and dragging when you hold down the shift key. So let's go back to the ground, hold down the shift key, and you can see when it's towards the end, it's a little sticky. I'm moving that end one that exists. If I move towards the middle, I'm creating a new one. And then the red, if I'm holding down the command or the control key, I can delete. And well, I can't delete the third one. I have to delete the third. Or I have to leave two. I have to leave 2 vertex to make an edge collider. I need at least 2. But if I've got more than 2, holding down the command key, I can delete one. So I can make a complex shape by holding down the shift key. And then if I don't like it, or my shape is too complex, delete it by holding down the control key until I have. I can't do that if I have only 2 points left. But as long as I have more than 2, I can delete them. And you'll see it turn red if you're holding down the control key. So we have this, we have our ground. So let's go ahead and get the catapult started. So we can drag the catapult sprite into the scene. And then let's frame select it on it by holding down the F key. There's our catapult sprite. Let's change that to catapult. And again, it's a bit too small for our for the scale that we have in our scene. So let's look at the original sprite object. And again, let's change our pixels to units to 50 and then hit apply. And we can see it doubles in size. We need to have this catapult work in our scene. And it needs to work in a rather complex manner. We have one arm of the catapult in the background. We have another arm of the catapult in the foreground. And then the asteroid needs to rest in the middle of it. And then we also are going to have 2 rubber bands, which means that our foreground arm can't really be on the same layer as the background arm. So we can set the entire catapult to our foreground layer. But we need to affect our order in layer to make this work correctly. Now, one of the solutions is we could take our artwork. Oops, I did not mean to open that. Let me just go ahead and stop that from opening up. Thank you. Go away. And we could cut apart our artwork. But we don't need to do that. We can also take our catapult sprite, our single sprite, and turn it into multiple sprites by using the Sprite Editor. And so let's take our original catapult sprite and change it from a single sprite to a multiple sprite. And with a multiple sprite, you can break up atlases and you can break up artwork into multiple sprites using the Sprite Editor. So let's go ahead and open this up in the Sprite Editor, which I've docked down here. And then let's create 2 sprites out of it. And I'm going to use the trim button to make these a little bit tighter. First thing I want to do is bring these edges in. So let me let's zoom in a little bit. And I'm going to go ahead and make this as tight as I can along this edge. And then I'm going to use the trim button. And the trim button will remove any excess clear space around the, any excess empty space around the artwork. And then I'm going to grab the second one and I'm going to move that into the exact same corner because this is going to help me later on when I try to place these 2. And I'm going to trim this one as well. And we can see now that I have 2 trimmed sprites in the Sprite Editor. And they, just to help me when I place them, they're sharing a vertex up here. And later on, we need to place our rubber bands, and we're going to place our rubber bands at the pivot point of these sprites. So I can grab and move the pivot point simply by grabbing that pivot point in the Sprite Editor and place them where I need them. And so these are going to be the origins of the bands at the center point of our sprite. So I'm just going ahead and placing them. You can see that it's down here under Custom Pivot. For more information about the Sprite Editor, you can also look that up on our website, on the Learn site. And so now that I've made my changes and I have my two sprites, I'm going to go ahead and hit apply. If we look at our image, we can see that it's now, that sprite 1, that Catapult sprite 0, is now missing its front arm. So we need to go ahead and drag this into the scene, our second arm. And I'm going to call this one Catapult front. And I'm going to make it a child of the catapult, so that they're so it's a child of the parent game object. So when I move that catapult, it's going to be behaving like the same game object. Then I'm going to go ahead and use my vertex snapping again. This is the important thing about the V key. Oops, come back here. Hold down the V key and go ahead and snap that to the vertex on the other sprite there. And so they line up seamlessly. Just a question. The ground is on a default layer. The ground was on a default layer, but now I'm putting it from the default sorting layer. The default sorting layer is still a sorting layer, and then I'm moving it. Then I moved it all onto the foreground so that it would be in the front. How do you open the Sprite Editor? Yes, thank you, from the Sprite Editor button in the inspector. Select a sprite and click on the Sprite Editor, absolutely. And then single sprites, you can't really do much editing other than the pivot point. Multiple sprites you can carve up into multiple sprites. And there's various ways you can do it automatically. You can do it by an atlas. You can do it by grid. So for more information on that, either ask me in Q&A or take a look at the Learn website, and you can take a look at it there. So now our catapult is set up. Let's go back to our game view. Let's back out a little bit. Let's grab that catapult. Remember, it's got a parent-child on it. So if I go ahead and grab it, I'm getting the whole thing. And let's go ahead and set it down over here somewhere on the left side, because we're going to be shooting left to right, and we want to give ourselves some space over here. Someplace that feels comfortable. Oh, that's a tiny sprite there. So let's go ahead and let me zoom in a little bit more and grab that someplace. Does that look good? How about over here? And you can see it's behind the grass, because we're leaving that order layer in 0. And then our catapult front, we want to bring up. And we need to get the asteroid and 2 rubber bands behind it. So we're going to have our back fork is going to be 0. We're going to have a rubber band at 1, an asteroid at 2, another rubber band at 3. So this one goes to 4. So we need to set up the catapult and the projectile and start to get it to work. So let's drag our projectile into the scene, and our projectile today is going to be our asteroid sprite. And our asteroid sprite, I'm going to rename this just sort of asteroid, looks too big. Now this is kind of the opposite that we had with the ground sprites and the fork, where they were too small. This one, for our game, is a bit too big. So again, we can come back to the import, and we can import the asteroid sprite, but we're going to go the other way. We want it to be smaller, so we want 200 pixels to units, and then hit apply. And we can see that asteroid now is a little bit smaller. It's hiding around behind, so again, we need to go from the default layer to the foreground layer, and then we want to put that in the middle. We've got fork is 1, rubber band, fork is 0, rubber band is 1. This is going to go to 2. Oops. Oh, these were on default. Whoops. Foreground. There we go. Sorry about that. Missed that part. So there we go. We're there now between the two of them. This is a physics game, so everything uses the internal 2D physics engine. So we need to attach a rigid body 2D to our projectile. So with our projectile selected, our asteroid, let's go ahead and add component physics 2D, and then we want to add a rigid body 2D. This is heavy. We want it to blast through those planks. So let's give it some increased mass. I figured out about 5 is good, so about 5 times base mass there. And when that asteroid flies through the air and hits the ground, we want to give it certain specific physical properties. First of all, I want to start off with it being kinematic, because when we use it in the game and we click it and we pull it, and before we let it go, we don't need it to be working under the physics system. We want to be able to manipulate that with our mouse. So I'm going to make sure that it's a kinematic rigid body when I go ahead and start. I also want it to slow down and travel through the air in a particular way. I want it to have some small amount of wind resistance, but not a lot. So let's give it a small amount of linear drag, which is how much it's going to be resisted, like air resistance flying through the air. But I want to give it a large amount of angular drag. So I think maybe about 1. And this way it'll travel far, but as soon as it hits the ground, it's not going to roll very far because its angular drag is going to be high. And this will make the gameplay a little bit easier. It's going to hit the grass and slow down very quickly rather than continue to roll. Now we need to give it some physical presence in the scene. So let's add another physics 2D component, in this case, the circle collider. And we can see it's sized to the size of the sprite, but our sprite is a little bit uneven, and also it's slightly smaller than the image of the sprite. So let's go ahead and grab that radius and bring it in a little bit. Find some good number in there. 56. Oh, looks good. 56. How about 56? So we have now a rough collider on the top with a size of about 56. I want to give it a material. When you look at colliders, all the colliders in the game, we can give them a physics material, or in the case of 3D, a physic material. There's no S in that. And we need to make a physics material 2D. And I want to make one that's got very high friction. And so that means when it hits the grass, it doesn't slide on the grass, it rolls on the grass, and then it'll slow down very quickly because we've limited that angular drag. So let's go back to our project and let's create a new folder. And in it, let's call it physics material. And let's create a new physics material 2D. And I want to call it high friction. And what do we want to do with our high friction? Well, surprisingly, we want a high friction. Physics material control the bounciness and the friction of the collider and how it interacts with the other colliders in the game. So we've got this edge collider along the grass, and how does our asteroid interact with it? Well, we want it to have a very high friction. So now that we've created this as an asset, we can go to our asteroid and we can add our high friction to that material slot on our circle collider. Oops, I skipped the save part. Bad me. Bad me. Take me out and whip me with a damp noodle. We need to save our scene. So let's go ahead and save this in, I like to have in a folder called _scenes, because I like my scenes to sort to the top, and I'm going to call this one main. Yeah, save early, save often, save before you play. I sort of had completed a set of development point, and I wanted to save that. And I should have saved it more often. I like to save more than that. But so now there's our main scene saved in the game. So now we have our asteroid set up. We need to attach this projectile to our catapult. And we're going to do that with a spring joint. And to attach the asteroid, which has got a rigid body, to another object, we need to have that other object also have a rigid body 2D. So let's go ahead and select the catapult, and let's add a component, physics 2D, rigid body 2D. And again, this is a kinematic rigid body because we don't want our catapult falling down under gravity. We want it to stay where it is, where we placed it, but we want it to have that physical rigid body characteristics. So now that we have something to attach our projectile to, let's add a spring joint 2D to our projectile. So let's select our asteroid again, and then let's add a component. Let's add physics 2D, and we want is a spring joint 2D. And the first thing we see is this green line shooting off into space. Well, what is it attached to? Well, if we don't have anything as a connected rigid body, we're going to be connected to the scene, to world space. And so we're anchored to origin of world space. We don't want to be anchored to origin of world space. We want to be anchored to our catapult. So let's just simply grab our catapult, which has a rigid body 2D on it, and we can put it into this connected rigid body, and pop, we are now connected to our catapult. When we're looking at the gizmo, and sort of a quick aside here, we'll see this in a minute, we can see that's telling us where our connection is to the projectile and where it is to our connected rigid body. And then there's this line here, and that is distance, which is the how far away from our anchor we're going to try to reach with our spring force, our spring joint. And we're going to leave that distance at 1. We're going to change the frequency to 5. And this is how quickly and how many oscillations it'll take, how strong is that spring to try to bring our object to that distance point. So we're going to set this up with a distance of 1 and a frequency of 5. And we can see that distance is going to try to reach this distance here from the anchor. So now we need our rubber bands. We need to set up our rubber bands. Question: why not use scale but use pixels to units? Some microscopic amount of optimization, because if you're scaling, you are doing some math. You're doing the transform. You're also, if you've got other things that are batched, if I believe correctly, by changing the scale, you could break batching, and it's just more efficient to change that on import, because you do it once when you're importing the sprite, than to do it in the transform every frame. So, our rubber band. For our rubber band, and someone was asking, what are we going to use for our rubber band? Our rubber band, we're going to use line renderers. So let's add a line renderer to our Catapult forks. And we can do this again with multi-editing. So I can grab the front and the back, and I can add a component. I can add an effect. I'm adding a line renderer. Now I can't edit these together, but I can add them together. Now I can edit them separately. So the most important thing to add is a material. We need to add a material to our line renderer, and then we also need to set the parameters. So to create a material, let's also create another new folder, and let's call it materials. And then let's go ahead and create inside that a new material. And I'm going to make a very simple material. I'm going to use transparent diffuse, and I'm going to call this new material Catapult band. And I'm going to set that material to be black. So just simple. It's going to be black, a little black band. We could be more complicated. We could probably come up with a little stretchy texture. Right now, we're going to leave our texture as none just to keep this as a simple project. And then let's go ahead and add that. So we can come back and take a look at our Catapult and our Catapult front, both of which have our line renderers, and then add the Catapult band there to our material. Now the parameters are how big is this line renderer going to be? And we need a little bit of sort of some faux perspective here. Even though it's a 2D game, we like to get that sense that there's a little bit of perspective in it. And we can see that the back fork of the sprite for our Catapult is smaller than the front fork. So when we're picking these size, let's have a start and end width for the back being 0.15 for both start and end. And then for the Catapult front, let's make it 0.17, just slightly larger. And that'll give us that sort of sense that there's a little bit of perspective going on. So this sets up our Catapult. And now we need to script the projectile and the rubber bands and the Catapult. And we'll be doing this in one large controller script. Now, before we get into it, this is sort of beginner intermediate scripting. And there are some interesting and clever ways that the author of this script did some things, which I'll try to walk you through one step at a time. Because of the volume in this script, I'm not going to be writing this out every line. I'm going to be pasting it in and describing it just to sort of save us some time. So I'm going to go ahead and create a new script. And that script is going to go onto the projectile. And that new script is going to be called projectile dragging. And when we create a new script this way, it just dumps it here in the root. So let's create another new folder, and let's call this scripts. And let's file projectile dragging away in scripts. And then I'm going to double click it and open that up here in MonoDevelop. This already should be increased in size a little bit for you guys, so hopefully you can read it. And I'm going to play a little dance over here where I'm going to be copying and pasting some lines from Sublime Text. The main thing that we're going to be doing inside projectile dragging is creating and affecting the line renderer and then working with the asteroid itself. So the very first thing we want to do is talk about the maximum stretch that we can have on the asteroid. So we've got our asteroid, and how far can we stretch it back before we want the bands to stop the asteroid? Because otherwise you could drag it, you know, all the way around the game, and we don't want to be able to do that. Oops, come back here. So we want to be able to have a limit to how far we stretch our asteroid from the target. And that is going to be something that we call max stretch. And we're going to set that as a default of 3 Unity units. And we can say 3F or 3.0F, whichever you prefer. And then the next thing we need to do is have a reference to the 2 line renderers, because these are the line renderers that we're going to be affecting. So we need a public line renderer catapult line front and public line renderer catapult line back. And these are going to be the line renderers that we are going to manipulate in our code. I'm going to go ahead and clean up these bits because we don't need them. And we need to set up our line renderer. And to set up our line renderer, we're going to create a quick function just called line renderer setup. And we'll call it in start. So we'll call line renderer setup at the start of our game. So we're going to declare that down here, void line renderer setup. The first thing we want to do is set the starting position of the line renderer. Where does it start? Well, the line renderer is going to start at the catapult line front. We're going to set the first segment to the catapult line front's transform position. So when we're looking at the game, we have on our catapult, we have our line renderer. We have its transform position, and that's the center point right here. Same with this catapult here. So we're setting our 0th or first segment to the transform position of the catapult. Then we want to set our order and layer. So we're going to set our sorting layer name, or we're going to set our sorting layer first to foreground. And then we're going to set our order and layer to 1 and 3. So does that make sense, what we're doing here? So we're defining references to our 2 line renderers, and then we are setting them up in a separate function so that it doesn't clutter our start, and we neatly call it with 1 line. The next thing we want to do is define what happens when we click on our projectile and move it around and then let it go. So we want to deal with an on mouse down and an on mouse up. So what we're going to say is on mouse down, we want to disable our spring joint, and then on mouse up, we want to enable that spring joint. So how are we going to do this? Well, the first thing we need is a reference to our spring. We can do that up here at the top. So let's declare our spring joint 2D as a spring, and it's private because we can grab that reference, and we can grab that reference in awake. So we say our spring is the spring joint on the asteroid. So our projectile, if we look at our projectile, it has the spring joint here. So we're just going to simply get that component. And then when we mouse down, we make sure it's false. And when we mouse up, we then enable that spring. So we click on it, we drag it, we fling it when our mouse comes up. The other things that we're going to be doing is we've got a onClicked, and that is something that just tells us whether we're dragging. We'll see this working in the update. So we have clicked on it when the mouse comes down. We have not clicked on it when the mouse comes up. And also when we let go, when the mouse comes up, we take our rigid body and make it is kinematic where it is false. So it becomes a dynamic rigid body and now works under the forces of physics. Now let's take a look at using these in our update. So in update, if we've put mouse down and we've clicked on the object, we want to drag it. So we're going to create a new function just for dragging. Oops, excuse me. When we drag the asteroid, first thing we're going to take is our mouse to world point. And someone was asking, how can we get that camera to world point? Well, we do that with, there are many different ways. You can look up camera in the documentation, but we're going to be using screen to world point. So we're going to take our camera and take our screen to world point, and we're going to say that input mouse position. And we're going to get from it a vector3 that we're going to call the mouse's world point. And then what do we want to do? We want to set our Z value to 0 because we're in 2D. We don't want any Z depth, so we can ignore the Z depth. We can simply just make it 0. And then we're going to say our transform position, which is the transform of the asteroid, is equal to our mouse to world point. So we simply find a point in the game based on where our mouse position is, set that Z depth to 0, and assign it to the transform. But what about the dragging thing? What about our max stretch? We don't want to be able to set this because with the current code, when we're dragging, we can drag this mouse position anywhere. We need to find a way to limit that stretch and keep it in line with where our mouse is. So if our mouse is over here, we want this in line. Let me just back out a little bit. If my mouse is up here, I also want to keep this in line as well. And so there's a rather clever use of rays that we can use. Normally with a ray, like we do with the ray casting, you can push a ray and you can say, hey, what have I hit with this ray? And you can define the ray by where it starts and what direction it's going in and how far it is. And you can say, hey, is there anything along this ray that I've hit? It's a very common way of using a ray. But we're going to be using rays in a very different manner. So let's set up a couple of rays that we can use to position our asteroid. So first one we're going to make is ray to mouse. We're just going to create a ray. And then in our start function, we're going to set it up. But we aren't going to define very much about this ray. There's our ray to mouse. It's going to become a new ray. And it's going to start at our catapult position. And it's going to have no direction because we're going to set this when we need it. How are we going to set this? Well, we'll set this in our dragging. When we drag more than our max stretch. So we could write, if catapult to mouse is greater than max stretch. But when you're comparing values and magnitudes, it's actually quicker and much more efficient to compare the square magnitude rather than the magnitude itself. So we're going to create for efficiency's sake, a private float called max stretch squared. So this is going to be our max stretch to the power of 2. And we can set that up in start, where our max stretch squared is equal to the square of our max stretch. And this allows us to do a compare up here if the catapult to mouse square magnitude is greater than our max stretch squared. And how do we get catapult to mouse? Sorry, I should have pasted this in the other order. I'm not used to dissecting scripts this way. But if we have our mouse to world point, we now need a vector 2 from our catapult position to our mouse to world point. And so that is the vector 2. That is the difference between our position here and our position there, and we get a vector. And so we grab our vector, and then if that vector's magnitude is greater than the max stretch squared, then remember our ray to mouse? Our ray to mouse direction is catapult to mouse. So what we've done is we have our ray to mouse as a new ray. We get the direction between the catapult and our mouse. And if we have gone beyond our stretch value, we then use the ray and we set the ray's direction to being the same direction between our catapult and our mouse. And then we find a point along that ray that is max stretch. It's actually rather clever. I mean, I first looked at this, it took me a second to figure this out. So what we're doing is we're saying that our max stretch, let's pretend, I'll visualize this with distance. Our max stretch is 3. That's 3. So if we're inside max stretch, we set the position of the asteroid to wherever we happen to move the mouse. If we go beyond max stretch, then we set the ray and then count along the ray to max stretch, and then we set the asteroid at that point, each frame. So then if I move it out to here, we look at the ray, look at the distance, set the asteroid. So that's what we do when we're dragging. So let's come back and look at our update. So our update currently only has clicked on, and if clicked on, we're dragging. The next bit that we're going to write is going to be whether or not we have launched our asteroid and how we're coming up to the launch point. So if we're in Unity here and we drag back and we let go, the asteroid's going to pitch forward. And what we're going to use as a signal is we're going to look at the velocity of the asteroid. And when it pitches forward and it reaches a point where it starts to pass our origin, it's going to start to slow down because the spring is going to pull it back. And when the asteroid starts to slow down, we'll use that as the indicator that we want to launch our projectile. And what we're going to do is we're going to disable the spring joint. Actually, we're going to destroy it. We're going to remove it. And when we destroy that spring joint, and we're going to turn the kinematic off, and the projectile gets launched, it's now free flying. It's under the control of physics. And we're going to use that point where we destroy the spring joint to talk to our script. We're going to use that as a flag in our script. So when the spring joint has been destroyed, we'll then change our logic. So let's come back to monodevelop. And so after we are dragging, so if our spring joint is not null, so if we still have a spring, we will have one set of logic, or else we will do something, we'll do something else. So that's what we're splitting it up in. So if our spring joint still exists, we haven't launched it yet, we do all the code in this block, and then when we've launched it, when the spring is null, we then do our other logic. So the first thing we're going to say is, if the rigid body is not kinematic, and when we let go of our asteroid, we set the kinematic to being false. So we are now a physics object. So if we are not kinematic, which means we have let go of the object, and our previous velocity, which we're going to have to grab, is greater than this frame's velocity, then what are we going to do? We're going to destroy the spring. And then we are going to assign last frame's velocity to our velocity. The reason for that is when you're coming across, and so you're gathering speed, you're going faster and you're faster and faster, and then the first frame you slow down, you don't want to see the asteroid get tugged for a moment and then fall to the ground. You want it to keep going at that nice velocity. So what we do is we notice that in this frame, our velocity is dropping. So we destroy the spring, we restore that velocity to last frame's velocity. Now, on the other hand, if we have not clicked on it, clicked is not on, then we're going to take the previous velocity and we're going to record this velocity and save it so we can reassign that. So we can test it and we can reassign it. And then lastly, we're moving things around in Update. We want to update our line renderers because we've set our line renderer here in our line renderer setup, but we need to update them every frame. So we're going to write a little function for doing just that. So line renderer update. So each frame we need to update our line renderer. First thing we want to do, again, is find a vector. We want to find a vector called the catapult to the projectile. And that's going to be the transform position of the projectile. And then we have a reference to the catapult, so we can grab that. So this is the projectile here and to the catapult. So we're finding this vector, the transform position of this object to the catapult's transform position. So we're going to make another ray. So let's come back to the top. And how are we doing this? This is very similar to what we did before with placing that object with a ray. So let's create another ray, and let's call it left catapult to projectile. Actually, I lied about that last bit. We're not going to be grabbing this side. We're going to be grabbing this point. We're going to be grabbing from the front fork to the asteroid. And so we have this ray, and again, we want to have another empty ray. That's going to be our left catapult to projectile. It's going to be a new ray that's going to start from that catapult front transform position. And again, no direction. It's a new object, but we are going to set it down here in the line renderer update. And we set it with the line renderer update here. So we get that vector 2 transform position of the projectile from the catapult front transform position, and we assign that to our ray's direction. And then our hold point, which is where we want to draw our band to, vector 3 in space, is going to be that left catapult projectile get point at the catapult projectile's magnitude, how far it is away. Now this is going to be a bit of a problem. We're going to start drawing our band from the front here to the center point. We're going to be selecting from center point to center point. It's not showing me what I want to show you, but you get the idea. So there's the center point on that one. There's the center point on that one. It's going to be drawing them together. We want to take it to the end. And we need to get the width or the radius of that sphere. So again, we need to set up a new reference up at the top, circle radius. And circle radius, we're going to grab a circle collider 2D called circle, and it's going to be our collider 2D as a circle collider 2D. Because we have to define which type of collider it is. And then we're going to say our circle radius equals the circle dot radius. So how do we end that? Our hold point is going to be the point of our catapult to projectile magnitude plus our circle radius. And then we simply need to set the second segment. Each frame, catapult line front, set position 1 to the hold point, catapult line back, set position 1 to the hold point. And then lastly in our update, our else. So right now, if we're clicked on it, we do dragging. If our velocity, if we're not kinematic, and our velocity decreases, we destroy the spring and launch our object. If we haven't launched the object, we save the previous velocity and we update our line renderer each frame. Or else, our catapult lines are disabled. Our enabled equals false. Now I hope this makes sense. We seem to be missing one bit. Catapult. We also need to have a reference to our catapult. Oh, dissecting somebody else's script. We've missed this, which is our transform catapult, and we have to set that. This is the reference and setting of the catapult itself. So we have a reference to the catapult, and we get that from the spring, which we know. Its connected body transform is the catapult. So we know the spring. Come back here. So we know our spring here. We know its connected body, which is the catapult, and we can get its transform position from that. So let's save this, And with all miracles, I won't have missed anything. Oh, we did. What have I missed? Clicked on. I have a typo. Oh, clicked on. We haven't set clicked on. I have to also declare that. And previous velocity as well, probably. Don't think I declared that. Hopefully you guys got the logic. It's a large script and a lot to dissect. Let's cut that back. There we go. Wow, what a miracle. So now that we've got that set up, we need to go to our asteroid, and we've got our catapult line back, our catapult line front that we need to set up. Let's save this. Let's hit play. And there we go. Stretch. And we can see that it's got that max stretch. So if I move it beyond our 3 units max stretch, it's going to stay and make a ray in the order of where my mouse is. Our band goes to the center point plus the radius. And when we let go, it's going to move forward, and it's going to let go of the band, and it's going to fly off. So we do that. Woohoo! So that's probably the most complicated part that we have. And to make it look nicer, we should probably set this a little bit closer up here so that we can still grab it, but it doesn't look too stretchy. There we go. We will upload the whole project. It'll become part of the 2D pack. So thanks for coming. You can follow us on Twitter. Follow us at Unity3D, at Mike Geig, at Will Goldstone, or myself at The Ant Ranch. And you can also post on the official thread, the free live training session thread on the forums, which you can find under the teaching section in the stickies. Thank you very much.